So, good afternoon, friends. We meet again today, and in this particular lecture, we are going to study about how to calculate the reaction. Before starting the lecture, let us recall what we have done in the last lecture. In the last lecture, we had studied about the reaction. How can we have the reactions in different types of supports? So, if you remember that for reaction, there are three important points that are to be considered. Number one, it is always produced at point of contact of two surfaces. Second important point, it is always at an angle of 90 degree to the surface. And third important point, it is always acting at the direction opposite to the motion of a body. Then we had studied different types of supports. What were the different types of supports? The different types of supports that we had studied were roller support, hinge support, fixed support. In the roller support, we have got only one reaction, that is horizontal. In vertical support, we have got two reactions, that is horizontal and vertical. And in hinge support, we have got fixed support, we have got two moments, three reactions, that is one is horizontal, one is vertical, and another is a moment. Okay, this much we had done in the last lecture. So this is the diagram which was depicting you about the reaction, that is the weight of the block will try to move the block in the downward direction, but the resistance is offered by the surface of the table in the direction opposite to the motion of the block, that is in the upward direction, and therefore there is a reaction produced in the upward direction. Okay, so now today what we are going to study is, we are going to study about how to find out the reactions. Okay, what is the procedure of finding out the reaction? So we have considered a simply supported beam of length L, and it is subjected to a 2 point loads of intensity W1 and W2 kilonewton, which are acting at a distance of L1 from support A and at a distance of L2 from support B. Okay, then you can also see that in the diagram, the distance between both the supports, that is support A and support B, is L. Okay, so the first point is, we have to describe the diagram. Which type of beam it is? It is a simply supported beam. Second, what are the loads acting on it? Two concentrated loads. What distance they are acting? They are acting at a distance of L1 and L2 from the supports. Okay, so these are the two distances they are acting at. Now, what is our next step? The next step is that we have to consider the system in equilibrium. To consider the system in the equilibrium, what we have to assume, that the three conditions, that is sigma h, sigma v, and sigma moment is equal to 0. As it is a coplanar non-concurrent force system, hence the condition of equilibrium for the system of forces is sigma h, sigma v, and sigma moment is equal to 0. If it would have been a coplanar non-concurrent force system, coplanar concurrent force system, then what would be the condition of equilibrium? Then the condition of equilibrium would have been sigma h is equal to 0 and sigma v is equal to 0. Okay, so in this case, as it is a coplanar non-concurrent force system, we have got three conditions. Sigma h means algebraic sum of the horizontal force, sigma v, that means algebraic sum of vertical force, and sigma moment means algebraic sum of the moments. Okay, when the term algebraic comes, that means we have to mention the positive and the negative. So in the horizontal, the positive is considered as when the force or the horizontal force is moving towards the right side of the point, and if it is moving towards the left side, it is considered as negative. Or we can say that if the force is acting in the direction towards positive x-axis, it is considered as plus, and if the force is acting towards negative x-axis, that is considered as minus. Okay, now if you see on the system or in the diagram, there is no horizontal force acting. So when no horizontal force is acting, that means the horizontal condition is already satisfied. Now we come to the second condition of equilibrium. And what is the second condition of equilibrium? The second condition of equilibrium is sigma v is equal to 0. Sigma v is equal to 0 means what? That the force, vertical force, that is equal to 0. Now vertical force, that means sign convention we have to consider. If the force is acting in the vertical upward direction, we'll consider it as positive, and if the force is acting in the vertical downward direction, we'll consider it as negative. Okay, so now if we see in the diagram, what we can see, that the VA, that is reaction at support A, is in the upward direction, so it is positive. Then W1 is in the downward direction, so it is negative. W2 in the downward direction, negative. And VB in the upward direction, that is reaction at the support, so it is also considered as positive. Okay, so what equation we get? VA plus VB is equal to W1 plus W2. Okay, now we come to apply for our third condition of equilibrium. And what does the third condition of equilibrium say? That is sigma moment is equal to 0. Now for sigma moment is equal to 0, what we have to do? We have to consider the sign convention as clockwise moment positive and anti-clockwise moment negative, right? Also remember one important point, that if you want to find a moment, you have to select a point at which the moment is 0. As it is a simply supported beam, so moment value will be 0 at the support, that is at support A or at support B. That means I can find out the moment about point A, or I can find out the moment about point B. Suppose we take moment about point A. Okay, so we have to find moment. What is the formula to find out the moment? Moment is equal to force into perpendicular distance. Which distance? Perpendicular. If force is vertical, distance will be horizontal. If force is horizontal, distance will be vertical. That is the one point. Second point, how much distance? So the distance between line of action of the force and the point at which moment is calculated. Which is the point over here where we are going to calculate moment? We are going to calculate the moment about point A. Okay, that means force into point A तक का distance. Now line of action हमको कैसे मिलता है? So line of action we get from either extending the point at which the force is acting in vertical upward direction or vertical downward direction. Okay, so if we consider that W1 is acting, we will forward the line in upward and downward direction, so we'll get line of action. So W1 का line of action till point A is distance L1. As it is a vertical force, distance will be horizontal. Then I had also told you that we have to consider the equation, the direction as right hand thumb rule. So the force, what is the right hand thumb rule? The thumb of the right hand shows the force and the fingers, they show the direction. So W1 is acting in the downward direction, so we'll show the thumb in the downward direction. So what are the fingers showing? The fingers are showing the direction is clockwise. So you can see that I have written W1 into L1 clockwise positive. Okay, then W2. What is the distance of W2 with respect to point A? L2. As W2 is also vertical, distance is considered to be horizontal. Okay, so W2 into what is the distance? L2. How will it rotate? So again, right hand thumb rule shows that the force is in the downward direction. Okay, so fingers are in the clockwise direction. So you can see what I have written, W2 into L2. Now the third reaction is WB, or the third force is reaction WB. It is acting in the vertical upward direction. So my thumb is in the vertical upward direction. Okay, and the fingers are showing which direction? Anti-clockwise. Okay, so when the fingers are showing the direction anti-clockwise, so it will be negative. So what you can see, it is VB into L and negative sign because it is anti-clockwise. So now what we get? W1L1 plus W2L2 minus VB into L. Now I want to find out what? I want to find out the reactions. What are the reactions? Reactions which are produced at the support. So here it is VA and VB. So I want to find out from this equation the reaction, and the reaction is VB. Okay. So W1L1 plus W2L2 upon L, that will give you the value of VB. Now I have obtained VB. I can substitute in equation 1, that is VA plus VB is equal to W1 plus W2. So I will get the value of VA. Okay, so you can see, substitute the value of VB in equation 1, that is VA plus VB is equal to W1 plus W2. So you get VA plus W1L1 plus W2L2 upon L is equal to W1 into W1 plus W2. So you will solve the equation and you will get the value as VA is equal to W1 plus W2 minus W1 plus W1L1 plus W2L2 upon L. Okay, so this is the procedure that is to be followed when you are solving any problem to find out the support reaction. What is step number 1? I'll speak in Hindi now. स्टेप नंबर 1 है, आपको क्या करना है? फ्री बॉडी डायग्राम ड्रॉ करना है. स्टेप नंबर 2, कंडीशंस ऑफ इक्विलिब्रियम आपको अप्लाई करनी है. कौन सी कंडीशंस हैं इक्विलिब्रियम की? सिग्मा एच इज इक्वल टू 0, सिग्मा वी इज इक्वल टू 0 एंड सिग्मा मोमेंट इज इक्वल टू 0. जब सिग्मा एच आप कंसिडर करते हो तो जो फोर्स राइट साइड पे जाता है पॉजिटिव, जो फोर्स लेफ्ट साइड पे जाता है नेगेटिव. ओके, then second condition is sigma v is equal to 0. What is the sign convention? Force ऊपर जाता है positive, force नीचे जाता है negative. Okay, and third condition is sigma moment is equal to 0. What is the sign convention? Clockwise moment is equal to anti-clockwise moment. Okay, now you have to apply all these three conditions on our diagram and you have to find out द रिएक्शंस. कहाँ पे रिएक्शंस फाइंड करने हैं? सपोर्ट ए के एंड सपोर्ट बी के. दैट मीन्स कि आपको क्या फाइंड करना है? वी ए एंड वी बी. तो सिग्मा एच की कंडीशन हम अप्लाई करते हैं. तो क्योंकि स्ट्रक्चर या बीम के ऊपर एक भी हॉरिजॉन्टल फोर्स नहीं है तो वैल्यू क्या हो जाएगी? 0. और अपन बोलेंगे कि जो हॉरिजॉन्टल कंडीशन है सिग्मा एच इज इक्वल टू 0 वो ऑलरेडी सेटिस्फाइड है. सेकंड कंडीशन क्या है हमारी? सिग्मा वी इज इक्वल टू 0. ठीक है, सो सिग्मा वी में फोर्स ऊपर जाता है पॉजिटिव, फोर्स डाउनवर्ड डायरेक्शन में जाता है नेगेटिव. सो वी ए इज इन द अपवर्ड डायरेक्शन प्लस, W1 डाउनवर्ड माइनस, W2 डाउनवर्ड माइनस एंड VB अपवर्ड प्लस. राइट, तो हमें इक्वेशन मिलती है VA प्लस VB इज इक्वल टू W1 प्लस W2. इसको हम नेम कर देंगे इक्वेशन नंबर 1. देन वी विल अप्लाई अवर थर्ड कंडीशन, सिग्मा मोमेंट इज इक्वल टू 0. क्या साइन कन्वेंशन है? क्लॉकवाइज मोमेंट पॉजिटिव, एंटी क्लॉकवाइज मोमेंट नेगेटिव। ठीक है, मैंने आपको बताया था कि दो बहुत इंपॉर्टेंट पॉइंट्स हैं जो हमें ध्यान में रखने हैं। सबसे पहला कि ऐसा पॉइंट सेलेक्ट करने का जहाँ पे मोमेंट की वैल्यू ज़ीरो हो, तो सारे फोर्सेस का मोमेंट हम उस पॉइंट पे लेंगे। तो मोमेंट की वैल्यू कहाँ पे ज़ीरो हो सकती है? मोमेंट की वैल्यू ज़ीरो हो सकती है सपोर्ट ए पे या सपोर्ट बी पे। हम लोग ले रहे हैं मोमेंट अबाउट सपोर्ट ए। ठीक है, दिस इज द फर्स्ट पॉइंट। दूसरा इंपॉर्टेंट पॉइंट है मोमेंट इज इक्वल टू व्हाट? फोर्स इनटू डिस्टेंस, राइट? अब फोर्स कौन सा? W1 है, W2 है, बट डिस्टेंस कौन सा? सो डिस्टेंस कौन सा होगा? लाइन ऑफ एक्शन से लेके पॉइंट जहाँ पे हम मोमेंट कैलकुलेट कर रहे हैं। हम मोमेंट कहाँ पे कैलकुलेट कर रहे हैं? हम मोमेंट कैलकुलेट कर रहे हैं अबाउट पॉइंट ए। दैट मीन्स जितने भी फोर्सेस हैं उसका डिस्टेंस मुझे कहाँ तक लेना होगा? पॉइंट ए तक का। जैसे W1 है तो उसका डिस्टेंस क्या होगा ए तक? L1। W2 है, उसका डिस्टेंस क्या होगा ए तक का? L2। रिएक्शन VB, उसका डिस्टेंस क्या होगा पॉइंट ए तक के लिए? L। ठीक है, सो लाइन ऑफ एक्शन से लेके जिस पॉइंट पे हम मोमेंट कैलकुलेट कर रहे हैं वहाँ तक का हमको डिस्टेंस कंसीडर करना है। ओके, सो दिस इज सेकेंड पॉइंट जो आपको याद रखना है। तीसरा पॉइंट, क्लॉकवाइज के एंटी क्लॉकवाइज। तो जैसे मैंने आपको पहले भी बताया कि राइट हैंड थंब रूल है। अगर फोर्स मेरा ऊपर एक्ट करता है तो राइट हैंड का जो थंब है वो ऊपर दिखाएगा और उसकी जो फिंगर्स हैं वो क्या दिखाएंगी? डायरेक्शन। ठीक है, तो अगर थंब ऊपर की तरफ है तो डायरेक्शन आपका क्या हो जाता है? एंटी क्लॉकवाइज। अगर मेरा फोर्स डाउनवर्ड एक्ट कर रहा है तो मेरा थंब जाएगा डाउनवर्ड। ठीक है, और जो मेरी फिंगर्स हैं वो क्या दिखा रही हैं? क्लॉकवाइज मूवमेंट। ठीक है, सो नाउ वी विल बी कैलकुलेटिंग द मूवमेंट अबाउट पॉइंट ए। तो क्या लिखा अपन ने? सबसे पहला फोर्स है W1। ए तक का डिस्टेंस कितना है? L1। फोर्स W1 वर्टिकल है तो परपेंडिकुलर डिस्टेंस कौन सा होगा? हॉरिजॉन्टल। सो W1 इंटू L1। W1 डाउनवर्ड एक्ट कर रहा है तो मेरा राइट हैंड का जो अंगूठा है या थंब है डाउनवर्ड है, एंड फिंगर्स क्या दिखाएंगे? डायरेक्शन मूवमेंट की, वो क्या है? क्लॉकवाइज। सो W1 इंटू L1, W2 इंटू L2 एंड VP इंटू L, दैट इज इक्वल टू ज़ीरो। ओके, तो इससे हमें रिएक्शन VB मिल जाएगा। ये रिएक्शन VB को हम इक्वेशन 1 में रखेंगे तो हमको रिएक्शन VA मिल जाएगा। ओके, so this we are going to follow for all the other numericals. Okay, now you can see over here that we have taken the steps how to find out the सपोर्ट रिएक्शन। तो पहला स्टेप है ड्रॉ फ्री बॉडी डायग्राम, जो शायद हाँ दिख रहा है। सो पहला स्टेप है ड्रॉ फ्री बॉडी डायग्राम। सो वी हैव टू ड्रॉ अ फ्री बॉडी डायग्राम। क्या होता है फ्री बॉडी डायग्राम? फ्री बॉडी डायग्राम इज अ डायग्राम in which we are making the system free from all the constraints. That means कि अगर रोलर सपोर्ट है तो मैं एक वर्टिकल रिएक्शन दिखाऊंगी, अगर UDL है तो मैं एक UDL के इक्विवेलेंट कंसनट्रेटेड लोड दिखाऊंगी या पॉइंट लोड दिखाऊंगी। सो वी आर मेकिंग द बीम टोटली फ्री फ्रॉम ऑल दी कंस्ट्रेंट्स। ओके, दूसरी कंडीशन है अप्लाई कंडीशन ऑफ इक्विलिब्रियम। बिकॉज ये नॉन कोप्लेनर कॉन्करेंट फोर्स सिस्टम है, सॉरी दिस इज कोप्लेनर नॉन कॉन्करेंट फोर्स सिस्टम, तो इसके लिए जो कंडीशन ऑफ इक्विलिब्रियम होंगी वो सिग्मा H होगी, सिग्मा V होगी एंड सिग्मा मूवमेंट होगी। ओके, देन वी हैव थर्ड स्टेप सिग्मा H इज इक्वल टू ज़ीरो। सिग्मा H का मतलब है एल्जेब्रिक सम ऑफ हॉरिजॉन्टल फोर्सेस इक्वल टू ज़ीरो। Then fourth step is sigma V is equal to 0, that is algebraic sum of all the vertical forces is equal to 0, and last is sigma moment is equal to 0. So clockwise movement positive, anti-clockwise movement negative. Okay, now we come to the first problem that we have solved, that is find support reactions for a simply supported beam as shown in the figure. ठीक है, सिंपली सपोर्टेड बीम है, इसके ऊपर दो पॉइंट लोड एक्ट कर रहे हैं 5 किलो न्यूटन और 10 किलो न्यूटन का। ठीक है, सपोर्ट ए है रोलर सपोर्ट, सपोर्ट बी है हिंज सपोर्ट, सी के ऊपर पॉइंट लोड है 5 किलो न्यूटन का और डी के ऊपर पॉइंट लोड है 10 किलो न्यूटन का। ठीक है, तो मेरा पहला स्टेप है फ्री बॉडी डायग्राम ड्रॉ करना. हाउ टू ड्रॉ अ फ्री बॉडी डायग्राम. तो जो पॉइंट ए है, पॉइंट सी है, पॉइंट बी है और पॉइंट डी है, वी हैव टू एक्सटेंड इट इन द वर्टिकल डाउनवर्ड डायरेक्शन. तो हमने एक्सटेंड किया, ओके, और ए और बी को हमने ज्वाइन कर दिया. उसके बाद ए इज़ विच टाइप ऑफ सपोर्ट, रोलर सपोर्ट. तो रोलर सपोर्ट में कितने रिएक्शन होते हैं, देयर इज़ ओनली वन वर्टिकल रिएक्शन. So we are showing one vertical reaction B है, which we have already discussed that why in roller support there is only one vertical reaction in our previous lecture. Okay, so I'm not explaining again over here. Directly we are writing that in roller support we have got one vertical reaction, that is VA. Then 5 kilonewton is a point load, so we don't have to change it. We have to put it in the same way at point B. C, then 10 kilonewton point load at point D, and last is VB, that is reaction. Hinge support. How many reactions are there in hinge support? There are two reactions in hinge support. One is vertical reaction and second is horizontal reaction. Okay, so now what we will do, we will apply our conditions of equilibrium. So you can see that in the first diagram I have drawn a, what we call it as a free body diagram. So first step is a free body diagram. Okay, now step 1, that is sigma h is equal to 0. There is only one horizontal force HB acting on the system, which is equal to 0, so it is already satisfying the horizontal condition of equilibrium. Then we come to the second condition of equilibrium, that is sigma V is equal to 0. What is sigma V is equal to 0? So sigma V, upward force positive, downward force negative. So what we get, that upward force is positive, downward force is negative. So 5 is in the downward direction negative, 10 is in the downward direction negative, then VA in the upper direction positive and VB in the upper direction positive. So we get VA plus VB is equal to 15 kilonewton. This is our equation number 1. Then we have step number 3, that is sigma moment is equal to 0. As I have already mentioned that moment is 0 at the support. Okay, with support, roller support, hinge support and simply support. Okay, so as over here roller A is a roller support and B is a hinge support, I can take moment of all the forces either at support A or at support B. Okay, so we are taking moment at support A. Now when we are taking moment at support A, so what will happen, moment at support A, force into perpendicular distance. Up to which point? Up to point A. Okay, because we are calculating the moment about point A. Now if you see over here that first is 5 kilonewton force. So what is the distance up to point A? 2 meters. Then 10 kilonewton force. What is the distance up to point A? It is 2 plus 3, that is 5 meters. And what is the distance of the reaction VB up to point A? 2 plus 3 plus 2, that comes out to be 7. Okay, now to find out whether it is clockwise or anti-clockwise, what we have to assume? We have to assume our right hand thumb rule. ठीक है, what does the right hand thumb rule say? कि जो right hand का thumb है वो force दिखाएगा. अगर force upward है तो right hand का thumb will be in upward direction और fingers हमको दिखाएंगी clockwise है कि anti-clockwise है. Same way left hand, अगर हमारा thumb या फोर्स डाउनवर्ड एक्ट कर रहा है तो थंब हमारा डाउनवर्ड डायरेक्शन में एक्ट करेगा एंड वी विल नो वेदर इट इज़ क्लॉकवाइज के एंटी क्लॉकवाइज विद द डायरेक्शन ऑफ फिंगर्स. तो अब हम देखते हैं सबसे पहला हमारा जो फोर्स है वो कौन सा है. सबसे पहला जो फोर्स है दैट इज़ 5, डाउनवर्ड एक्ट कर रहा है. सो माई थंब दैट विल शो इन द डाउनवर्ड डायरेक्शन. ओके, तो मेरी फिंगर्स कौन सा डायरेक्शन दिखा रही है? क्लॉकवाइज. तो आप देखोगे 5 और इंटू 2, क्योंकि 5 का डिस्टेंस ए तक का कितना है? 2, और कैसे रोटेट कर रहा है? क्लॉकवाइज. ओके, देन 10, कितना डिस्टेंस है अप टू पॉइंट है? 3 प्लस 2, दैट इज़ 5. Again, forces in the downward direction. So fingers are showing the clockwise direction. So 10 into 5 clockwise. और लास्ट है VB. कितना डिस्टेंस है VB का? Up to point A, 2 plus 3 plus 2, that is 7. VB ऊपर एक्ट कर रहा है. So right hand का thumb is in the upward and fingers आपको दिखेंगे direction, that is anti-clockwise. So it is minus. So you can see my equation, moment about point A. What does it say? Moment about point A. Moment about point A means 5 into 2 clockwise, 10 into 5 clockwise, and VB into 7 anti-clockwise. Okay, so we get an equation 10 plus 50 is equal to 7 VD, and with respect to that we get the answer as 8.57. हमारी जो पहली इक्वेशन है वो क्या है? VA प्लस वी बी इज इक्वल टू 15. तो उसमें अपन VB की वैल्यू सब्स्टिट्यूट करेंगे तो आपको क्या मिल जाएगा? VA that comes out to be 6.43 kilonewtons. Okay, so I think this is sufficient for today's lecture. I have taken a very simple example so that you understand how to find out the support reaction for a simply supported beam subjected to point load. In the next lecture, we are going to find out the reaction for a simply supported beam subjected to uniformly distributed load. I hope you have understood what I have taught. If you have any queries, you can ask me, you can question me. And if you like my video, please share it amongst your friends, subscribe it, and please click the like button. Thank you.